Like they said, or she said you could bill her, or she could bill you, or I don't know. I haven't done this before, so we're learning. Okay, so we're finishing variation. So we can write problems into a variation equation, and we can write them as a word statement. So basically we're kind of going backwards. So we could basically rewrite this volume equals 2 pi r squared times height. This is the volume of a cylinder formula. And we can write it as a variation-like statement. So we could say it's directly proportional or inversely proportional or jointly proportional or whatever the equation represents. So I guess the first part that I would do is figure out what is representing the k value or the constant, the variation. Okay, the 2 is part of it. Because 2 is a number, so that's not going to be in my phrase when I write it out. Yeah, pi is also a number, so that is also the k value. So k in our case is 2 pi. So when I write this verbal phrase that represents this equation, I'm not going to write 2 pi in it because that's the k. I never specify what the k is when I write it out. So, is this direct variation, inverse variation, or like joint variation? Yeah, so I can have in my phrase jointly proportional. And then we always go in order, so V represents volume. So when I write it up, I can say the volume is jointly proportional to, and then does anybody else know how to write the rest of this? To, what did you say? Okay. So technically I should be more picky about how we say R and H. Like we should actually write out what does R represent, what does H represent. So anyone want to say to you guys what R and H are? Yeah. So I should use the whole word, not just the letters. If the letters represent something, you should write out the word. But if they just give you like Y, X, and Z, we don't know what they actually represent, so you just use the letters. Okay. So that's one kind of problem. So we have this problem. They give you a lot of information, a lot of words, but we need to write the variation equation based on these words. So the first sentence is basically giving you how to set this problem up in terms of an equation, and then it gives you all the information that you need to substitute into the equation that we wrote down. Okay. So the first sentence is basically giving us a setup. They don't give us any variables, so I can make up whatever letters I want to use to represent all that information. So, I guess if we're separating it, we have this lovely varies jointly. So that's basically where my equal sign is at. So everything in front of varies jointly is my first variable, whatever it equals. And so what variable do you want to represent the force of the wind blowing on the vertical surface? F, basically this whole thing is just talking about the force of the wind. So we know it has to be F equals. So then the other piece of the information is area of the surface. And what letter do you want to represent area of the surface? I mean, it's area, so I'd use A. And they said, and the square of the velocity. So that's the other piece of information. Yeah, so then times v squared. So this is how we're going to set it up. I should write in my k value. Basically, I need to figure out what number this is being multiplied to. The variation is always a multiple. So then the second part of it is giving me what information I need to plug into F, A, and B to find k value. So we have a wind of 40 miles per hour. Exerts a force of 50 pounds on the surface of half feet squared. So does anybody know what 40 miles per hour is representing? Yeah, I would say velocity. Velocity is like a speed, so miles per hour is going to be our v. So that's 40 squared. And then 50 pounds would be the force, and they specify that for us. So then 1/2 is area, because it has a unit that's squared, so that represents area. Okay. So then simplifying solving for k, what is 40 squared? 1600, and then still multiplied by 1/2. So 1600 times 1/2 is 800. And then getting k by itself, we're dividing by 800. And I'm going to write this as a simplified fraction. The zeros come out, but 5/80 simplifies to. That's what I was thinking. Yeah. Okay. So then I can go back up to here and write that in. So here's my declaration equation, which I don't necessarily need, but it's helpful so that way I can actually find the force. So I can substitute 80 miles per hour in and 2p squared to find the force on this vertical surface. So we know the area is 2p squared, so 2 and then times p squared. Yo. 80 squared is. Okay. I guess I'd probably do 6,400 divided by 16 if I'm in the full math. Unless you just type it in your calculator. So I was thinking that was 400. And then times 2. Yeah. And they said, do we have a unit for force? Okay. Good with that? Here's our last lovely little equation. Short problem. Yeah, if you don't want to open it. I wish you could take a picture of somebody with your phone and save it onto this picture. Wouldn't that be cool? Someone needs to create that. Like it works in my head, there's no way that would work out. Technology wise.
It's like a highlighter sort of, and then it transfers the words from there onto your iPhone.
Weird. I'm gonna Google that because that is not like looking like how that would even like work
I
out.
saw like, where you invest in this for college?
Well, there's Mrs. Ben has like these little square like triangles that go in the corners of her whiteboard. She can like take a picture of it, and whatever she writes on the whiteboard, it takes a picture of it. There's like when you use an app, it's that app she has, yeah. But it works.
It's just so
Yeah, it's rocking.
Yeah, I've heard about that stuff. Anyways, we should write out our equation, so yikes. Okay, number of vibrations per second of a steel guitar string varies directly as the square root of the tension and inversely as the length of the string. Okay, so the first thing is varies directly. So on the left side, varies directly. What are we even talking about? Okay, so we can use peak pitch equals, and then I have my k value. So then we have square root of the tension. So how do you want to write that? Square root 2. And then I have this inversely as the length of the string. So inversely would mean over dividing. And then, I don't know, use like L for length. Works for me. Pocket, is it? Oh, good. Well, I don't want to make it too complicated for you here. Okay, so just like always, we need to find the k value. So we have the number of vibrations per second is 50. Tension is 225 newtons, and the length is 0.6 meters. So 50 is representing what? The pitch, the vibration. And then 225, I said, was the tension, which is nice because it's a square. Length is 0.6. So then you can simplify myself for k. Does anybody know what the square root of 225 is?
No, I don't know.
15. I guess if I was doing that, I would multiply by 0.6. Don't necessarily need to do that. You could have divided 15 and 0.6 together. I just know what 50 times 0.6 is. It's 30. So then the k value is? Okay, so now we can use our variation equation to find the number of vibrations or our pitch variable. So plugging in tension of 196. Does anybody know what the square root of 196 is?
13 or 60.
No. 13 is 169. 16 is 256. 14. Yeah.
And there's one that was 60.
Right. Yeah, I don't know what that is. 28 divided by 0.65. Um, okay. And then does anybody know what our unit is? Okay. Super fun.
I go talk to Ro.
Yeah, do you want to go give these to him? Thanks.
That's good, yeah.
I have the music room to help Emma do the reindeer game.
Back in progress.
Sure.
So you want me to come back either way?
Well, just whenever you see me next time,
That's okay.
Like you're saying, give a hard time on the way there. Like, I'll really want to give a hard time. Well, then,
Did we all write the homework assignment down?
no.
Okay. Okay.
I probably won't be back. I mean,
He
I'll
needs
be
to.
back. Won't be back.